record. So multiply the entire right-hand side by 3 there. Now, the 3 and the 1/3 cancel. We're left with s minus 2 equals 3s plus 4. At this point in time, plus 12, thank you. What did I not do? What did I forget to do? Distribute. Okay. At this point, what should we do? Move the, what do we call them when we can move them around? Like terms. Very good, Natalie. Let's move the like terms around. So it doesn't matter which way we move them. We're going to get a negative answer anyway. So I'll say let's move the 12 over. All right, so we're left with s minus 14 equals 3s. Move the s over. Negative 14 equals 2s. So s equals negative 7. Okay? Questions on that one before we go on to 28? All right. 28. Tell whether each number at the right of the given equation is a solution of that equation. We've got u to the third minus 7u minus 6 equals 0. And it gives you two numbers to the right. It says 1 and negative 2. So we're trying to determine if 1 and negative 2 are solutions to the above equation. Now, some of you might want to think, all right, well, maybe I could try to factor this, but right away you're going to notice it's u cubed. And there may be a way of factoring it using grouping method, but for this one there's not going to be. So you can't try and factor to solve the equation. So how else could you check to see if these actually are answers to the equation? Yeah. Whenever you want to check if something is an answer, plug them in. Okay? As the u value. Yeah. So let's plug in a 1 for u. We get 1 to the third minus 7 times 1 minus 6 equals 0. 1 minus 7 minus 6 equals 0. Is that 0? It's clearly not, right? This is not true. So 1 is definitely not one of the solutions. Did negative 2 work, those who checked it? It did? Okay. So run through negative 2 and check that. Does that make sense?
Yeah.
Okay.
I actually have a question on 1626.
1626. Let me write it down and then we'll go back to it, okay? All right, let's do 48 first. That was the one Liam asked. That's okay. I was writing it down so we could do it afterward. So number 48 on section 1.7 says, first of all, the question says the following. In each formula, substitute the given values of the variable. Then find the value of the variable remaining, which is printed in red. All right, so 48 is the area of a cylinder. First of all, let's talk, I know we're not in geometry, but I think a cylinder is kind of a cool shape. Cylinder has two circles, right? One on each end. Now, if I were to take a cylinder like a soup can and cut it down the height of the can. So here's one top, here's the other top or the bottom. I cut it down the length of the can. What's going to be?
It's going to be a rectangle.
It's going to be a rectangle. Why?
What do you mean?
Why is it going to be a rectangle?
Because it's like, I don't know.
Can you
When
explain
cut it
why?
down the center, it'll be
Show us with a piece of paper why it's going to be a rectangle.
okay.
Stand up. Show. So when you cut a cylinder down the height, she said it's going to be a rectangle.
Okay, you got it.
And now, here's the interesting part about a cylinder. Hold still, no, stay there. This is the height of the cylinder, right? Here's the height. But what is this? We're not going to call it the length of the rectangle. What is it really? The circumference of the circle on the top or bottom. Thanks, Tim. Circumference of the circle on the top or the bottom. So when we look at this formula here, I know they're giving it to you, but just so we know what the formula, okay? So for total area of a cylinder, we've got area equals 2 pi r plus h. You know where this comes from? 2 pi r squared plus 2 pi r h. The 2 pi r squared is the area of the two circles. 2 pi r h is the circumference times the height to give you the area of that rectangle. So if you were to distribute this out, the first term would be the area of the two circles together. The second term would be the area of that rectangle that unfolds. Just so we're clear as to why this equation makes sense. Now, it says the area is 100 pi. Why is that convenient?
so you don't have to plug in anything for pi.
Yeah, the pi's are going to cancel, right? Isn't that convenient that they do that? A lot of the time you're going to see that on tests like this. Okay, even the SAT, they leave things in terms of pi so that the pi's cancel in the end. So this problem asked us to determine the value of h. Okay, determine the value of h. Then it says, let's see. Oh, that's it. Just find the value afterward. Okay. Oh.
Yeah, it's too.
Am I really? Oh, gotcha. Just the numbers. Just the numbers. Whew. It looks like the exact same problem if you look at them. Because if you run right down, they both have the same area, then they have... All right. All right. Thank you. So let's plug in the 80 pi for A and the 5 for R. Remember the other day when we were doing these kind of problems? What was the other way I told you could solve these? Instead of plugging in the numbers first.
The generic.
The generic. Let's do that. Let's take a look at the generic. So, everybody see, what are we looking for in this problem? Which variable? So what do we call the other variables? What did I tell you to do? Call the other variables blank. Fill in the blank. Who remembers? I wrote it in your notes. It was a note that we wrote at the top of the example for this one. Give it a shot. You sure? Come on. I'm sure it's not silly. I'm sure other people are thinking the same. Nobody? Come on. Constants. Very good, Francis. Very good. Let the other variables be thought of as constants. Now, if r was a constant, right? If r was a constant, that means that this would be like a number in the front, like a coefficient. How would you get rid of a coefficient? Divide it. So let's divide by 2 pi r on both sides. What happens to the 2 pi r's on the right side? Cancel, whoops, cancel, and cancel. So, my next line looks like the following. We have a over the 2 pi r equals r plus h. Easy enough. How do I get h by itself now? I want h alone. What do I do to get h by itself? Subtract the r. Okay, let's just subtract the r now. So we've got a over 2 pi r minus r is equal to h. That's the generic solution for the height of the cylinder, okay, in terms of its area and its radius. Again, in terms of the area and the radius, that is the height. Now, at this point, we could plug in to make it easier. We know the values of everything else. We were told what those values are. I'm telling you now, just so you know, you're definitely going to have a problem like this in the test. Absolutely, 100% will have a problem like this. Where you have a formula, and I say to solve for the generic solution, and then I give you the next step to plug in numbers. Okay? So you want to practice from number 43 all the way to number 50. Those are examples just like this. So you could try any one of those to help you on the home over the weekend. Plugging in, the area was 80 pi. The radius was what, 5? And then we subtracted 5. The pi's cancel, God bless you. The 2 times 5 is? So it's 80 over 10, which is 8. So it's 8 minus 5, which is 3. What are the units? What are the units for this problem? No? Anybody? I don't think they give you units. I will give you units, for sure. Okay? So if the problem said that the radius was measured in centimeters, or that the area was measured in centimeters squared, then your answer for height, units would be centimeter. Here you could say 3 units. You could write the word units. You're not given a dimension, but you'll be given a dimension for sure. Okay? Because numbers are meaningless without dimensions. Right? If you think about it. If I said 5, does that mean anything to you at all? No, really. 5 centimeters, 5 miles, 5 kilometers, 5 light years. Totally different things, right? So units really do mean a lot when we talk about numbers. What was the next one you said? Section 1.6. What number on section 1.6? That's all right. Do you want me to go check?
It was 28.
20.
And 26. Sorry, I was 26.
On 1.6 and then 28? Okay. Evaluate the expression for the given values of the variable. All right, so we're just plugging in numbers. Let's take a look at this one. So for 26 first, we've got x squared minus 4, quantity x squared minus 4 times the quantity x minus 3 all over the quantity x plus 1. And we're told that for number 26, that x could take on 3 different values, 1, 2, or negative 2. Is that what you missed?
No,
You tried to solve?
So,
Somebody else did that. Who else was that yesterday? Somebody came up to me and said the same thing. And it's tempting to want to solve this because you think it's an equation at first, but there's no equal sign.
yeah.
The problem said to evaluate the expression. So all you're doing is plugging in 1, getting an answer. Plugging in 2, getting it. Is that cool? Okay. Let's go on then. And same thing for 28.
Yeah.
Okay? Again, 26 and 28, all you're doing is you're asked to plug in the number and come up with an evaluation. So if you plugged in 1 up here for those 3 x's, what do you get? Then do it for 2, and then do it for negative 2 after that.
I have a question just like about the answer.
Sure.
To 1, 2, number 44, because I got like a really big number.
For section 1, 2, and it's number 44.
Yeah.
All right. This is the one with the G's and the H's. Didn't we do this one already? Could have sworn we did this in class. G squared plus H squared. We did.
I thought we did the one before.
Oh. No, because we did G's and H's on the board. I'm 100% sure.
Pretty sure this is the one that I got a million, like, it's the longest answer to, and then we simplified it. And I
Yeah.
got it right.
Yeah.
That's part of the problem set, though, right?
Yeah. Oh, it was on your homework and the problem set.
Simplified answer to.
What was the simplified answer for that one again?
Wait, oh, I have it.
Austin.
That was 6 2/3 or 20 over 3.
20 over 3. Yeah.
20 over, I got 5,600 over 63,900.
So you need to learn how to reduce. Start figuring it out this weekend. Let her figure that out though.
I'm using an app.
You can use your calculator
I know.
and divide the two numbers and then hit math, enter, enter to convert it back to a fraction. It'll put it in lowest terms. Always. Do you have your TI calculator with you?
Use that thing.
You need, guys, I told you to have a TI 8384 for that reason, so we can generalize.
So good, I never knew that because like you always invest.
Of course,
How
yeah.
am I possibly going to
Put a crazy large fraction in, hit math, enter, enter. It converts that fraction to lowest terms.
Can you enter?
Okay, always.
56,000 over 60.
Any other questions on the problem set?
Whatever, yeah.
Chris? 1, 2, 50?
What do I enter?
Let's take a look. Let's take a look. Oh, okay. Insert the grouping symbols. These ones are fun.
I don't understand this 78,000.
This problem is such going to be pretty interesting. Can we use that as a practice problem set? Learning how to do a problem set?
The grading will be more lenient on this one for sure than it will be on the future. All right, let's take a look. These ones are really interesting because what do you have to do here? What do we talk about? Yeah, you have to kind of guess and try and pick up on patterns in the beginning, but it's tough. So in the end, we want to get 3 as our answer. Right? We want to get 3 as our answer. So where can we start? Would it be worthwhile to start by, we could put parentheses around 6 and 5, because normally you would multiply first, right? The 5 times 2. So maybe they want us to put parentheses around the 6 and the 5. So we could start with that and see if it helps. Well, that would be 30 times 2 is 60. Well, then we're going to have 7 divided by 2 times 2. That's going to be 7. 60 minus 7 plus 1, that doesn't work, clearly. So those parentheses weren't a good choice.
What number is this? Oh, I have this right. Shout out to
What else could I try? Again, certain parentheses have no significance. It would make no sense to put parentheses around the 5 and the 2, because you have to do multiplication first anyway. You see what I'm saying? So that's how you can rule out putting them here. Worth, give me one.
Around the 2 and the 7.
2 and the 7? Like that?
Yeah.
Let's take a look. That would make that what? Negative 5 times 5 is negative 25. Divided by 2 times 2 is going to be no effect on the problem. That'll be negative 19, negative 18. So maybe that works with another one.
Well, you could put around the 6 and the 5 and around the 2 and the 2. And then it would be like 11 times 2 minus 7. And 22 times
All right, let's see
would
this.
be 11 times.
So get rid of the parentheses after the 7, you're saying?
Yeah. And put it around the 2 and the 2.
Like that?
Yeah, right. So
But that doesn't matter. It doesn't change the effect. Right? How does that affect the problem at all?
yeah, you don't.
Because, right, the 7 divided by 2 times is the same thing, really.
Wait, what did I do?
Oh, no, I see what you're saying. I see what you're saying. That works. Because you're going to make that a 4.
Yeah.
Okay.
Instead of putting around something else, alright. So 6 plus 5 is 11 times 2, 22 minus 7 is 15.
No, but then you need parentheses like this. Hold on. You need a bigger parentheses like this.
And you need to do parallels.
Okay?
Alright.
If you want to subtract the 7, that works.
And then would be 15, right? And then 15 divided by, which would be the 2 plus the 1.
You want to put another brackets here, I'm guessing, right?
Yeah.
Okay, that's what I was
That
thinking.
would be 5, and would be 15 divided by 5. Is 3.
You just ruined my life. It should be so long. I'm so excited.
Well done, Arthur. Very good. So, why is this one so much more difficult? You had inner brackets and then outer brackets as well. Okay? Well done. Very good.
Who's going to be on the test?
Not something that extreme. Not that kind of one.
How are you
No.
supposed to even do that?
If I gave you one of these, it might have like 3 or 4 numbers only, just to see that you can move parentheses around. Okay? But again, this is something that would be like a challenge one. It wouldn't be on your test because it would just take too long. It would eat up like 5 to 10 minutes if you tried all these different possible answers. We have about 2 minutes left. Can I go over the format real quick, please? So, you're going to have 4 questions, multiple choice, worth 2 points each. Okay? Then you're going to have a bunch of questions worth 1 point each. I don't know what the number is. Let's say 20. They're not going to be long, though. They're going to be short answer, like example. Give an example of an integer. Give an example of a rational number. When you multiply a negative times a positive, it's always a positive, true or false. Stuff like that. So quick 1-pointers. So you're going to have about 20 of those, and they're either going to be true, false, or short answer. And they're going to be worth 1 point each. Around 20 or so. But again, they're not going to take you long. They're going to take you like 10 seconds. You read it, you put a number down. Give an example of an irrational number. Square root of anything that's not a perfect square. So square root 2. You're done. So make those your quick answers, okay? After that, you're going to have a good amount of solving equations. Let's say, for the sake of this being 10. Solving equations. Okay, and those are going to be worth anywhere from 4 to 5 points. You're going to have, at the end, 3 word problems. And those are going to be worth 6 points each. And in there somewhere, you're going to have like 2 5-pointers also, where you have to fill in like charts and like talk about like, remember how we talked about the real numbers and how inside the real numbers you have your subsets of numbers, where you put like integers in there, you put whole numbers and natural numbers or the counting numbers. Then we talked about rational as one side, irrational as the other. You need to be able to fill in some sort of a chart like that, so know your number systems. Remember the example we did with the number line? And I said find a point 2/3 of the way from A as it is from B. One of those for sure. One of those. I give a 4-point reflection question at the end, which is you just have to answer. If you get the point, so don't leave it blank. Okay, I'm just going to ask you some questions about the class so I get feedback. It's worth 4 points. Make sure you answer it. Don't leave it blank. Everybody should get 4 points on that. There's no extra credit in the test, no. The 4-point freebie is my extra credit version because it gives you 4 points off the bat. Yeah.
Do you know what day your birthday is?
The date?
Yeah.
It's okay. All right. Guys, if you have a question over the weekend, email me. Listen, you can make a notability file of something you're having trouble with and email it to me or put it in Dropbox and say, I'm having trouble with this problem, can you show me where I went wrong? Instead of trying to email numbers, okay? So make a document and send it to me if you need help. Thanks, Felipe.